Congratulations. Now you've made it to the eighth grade math section, and it's some more volume stuff. We've got volume of a cylinder, a cone, and a sphere, how this is different from the previous volume questions. These things were polyhedra. An individual polyhedron is made from polygons. And then you can see there's no polygons associated with these three types of shapes. You got circular kind of things, very smooth curves. These are called solids of revolution. The reason why they're called solids of revolution is something that we'll get into this year. I'll give you a preview of it, and it goes like this. Let me draw a little rectangle inside of this cylinder. And now imagine taking this rectangle here and then spinning it around an axis, and that axis is actually the height here. So if I make this the axis, if I spin this rectangle around the axis, it generates that cylinder, which is why it's called a solid of revolution. Anyway, we want to find the volumes. Write the formula for the volume of the 3D solid using the given variable lengths. R stands for radius, H stands for height, of course, and we have the volume as pi r squared times height. Pi being, of course, that ratio of the circumference to the diameter of any given circle. That's kind of a clue to one of the previous questions that you had on this worksheet packet. And then pi, whenever you're using these formula, make sure that you use the pi key that's in the calculator, or alternatively, you can leave that pi there. Remember, we had a discussion about the difference between an approximate answer and an exact answer. Leaving your answer with a pi in it, like 13 pi, is perfectly acceptable. Okay, now I'm going to make kind of a connection between the volume of a cylinder and the volume of a prism, and tell you that they are basically the same exact formula, because the shape of the base here is a circle, and the formula for the area of the base of a circle, of course, is pi r squared, which is what we see right here. It's b times h. It's the same exact formula. Okay, cones. Kind of like the relationship between a prism and a pyramid, you have a similar relationship between a cone and a cylinder here. And if I had this same exact radius and the same exact height as this cylinder here, it would take exactly 3 of these cones to fill up that cylinder, which means that its volume is 1/3 pi r cubed, squared, multiplied times the height. And you might be wondering what the heck this L is. It does not come into play as far as the volume goes. It is used in surface area, and that thing is called the slant height. We don't use the letter H for it because, of course, that's the perpendicular height of this. You can see that there's a right triangle in here, and since the slant height is across from the right angle, it's the hypotenuse, it's actually bigger than the actual height. Very easy to get these things confused. We want to use the height within our volume calculation, not the slant height, okay? And then finally, we have a sphere. Sphere formula is 4/3 pi r cubed. There's this guy, Archimedes. Archimedes is the Greek mathematician who first approximated pi as 3.14. He is also the guy who's associated with coming up with the volume formula for a sphere. He thought it was one of his greatest achievements, although he achieved lots of stuff in mathematics. Now, there is an interesting relationship that Archimedes found between the volume of a sphere and the volume of a cylinder, which we will see this year in geometry. Now, as far as 38 through 40 goes, use the above formulae to solve each problem, and they correspond very easily here. You can see that this says cylinder. This one says cone. It also looks like a cone. Boom. And we're talking about the Earth being modeled by a sphere here, so obviously we're using the sphere volume formula. And as far as it goes, just like with any formula, we want to be able to work it forwards and backwards. Forwards means that we have the independent quantities like the radius and the height, and then we would solve for the volume. Working it backwards means that we already have the volume and at least one of the independent variables, and then we have to solve for the other one. And that's what happens on 38. A cylinder has a height of 8 centimeters and a volume of 402.124 cubic centimeters. Notice the cubic for volume here. What is the length of the radius? So here's one you're going to have to work backwards. Since this has an r squared in it, here's a question for you. If you isolate your r squared is equal to some number, how do you get rid of the squared there? Remember this inverse operation thing? You're going to take the square root. It happens on the Pythagorean theorem. It happens here too. Okay. On both 39 and 40, these are not backwards, these are forwards. To the nearest hundredth, so we're going to round our answer, just like you can see, these are rounded decimals. What is the volume of the cone? Now, even though you are rounding it, don't round it until the end. Still use your pi key on your calculator. Once you get your final answer, that's when you want to round. Now, pay attention here. Don't get fooled that this 19.86 is the diameter of the base, but that is not what we want here. We want the radius, so you'll have to do something to that, of course. I think something similar happens on number 40. The Earth can be modeled by a sphere with a diameter, there it is again, diameter of approximately 7,917.5 miles. I measured that myself. To the nearest cubic mile, so we're going to round this to a whole number. What is the volume of the Earth? So very similar over here. The actual formula needs the radius, but you're given the diameter, so you'll have to do a little bit of something to it in order to find its volume.